Good evening. We are Team Biohazard, and our proposal for longevity and increasing lifespan in people is an alternative treatment for FLE, which is frontal lobe epilepsy. It would be more affordable and less invasive using thermotherapy. And sorry, I'm kind of blanking. It has supporting software algorithm to prove that it is possible, and it could better be implemented with more research, but should be effective if it were to be implemented.
All right, so there are three main things we want to cover with background information about, what epilepsy is. So epilepsy is a neurological condition that can be characterized by slight behavioral changes due to seizure development. Now, in epileptic cases, the seizures are a lot less obvious than non-epileptic seizures. So it's kind of harder to designate when an epileptic patient is experiencing a seizure. And epilepsy is experienced by 1.2% of the US population, but in the world, it impacts more than 65 million people, and it is rapidly growing. And this condition can actually cause death in patients due to suffocation if they have a seizure and they roll onto their face and can't breathe, or brain damage due to prolonged exposure to seizure conditions. And these are primarily diagnosed using an EEG, which is a signaling program that can scan brain activity through electric potential, and that can be implemented by doctors or even some signal processing algorithms to kind of see how these kind of conditions can affect different people. And one example is NeuroSky. You could go back, actually, sorry. NeuroSky, which is a biosensor that Andres is wearing, say hi. It's a cheap and at-home EEG scanner that you can wear, and it can, in real time, track your brain activity, and it can connect to different computer algorithms that you can download on your own computer. Next slide. All right, so our proposed research alternative treatment is thermotherapy, and this can be administered through either cold shock or heat shock. So hyperthermic induction, heat shock, can lower your brain activity as a survival response, actually. And sometimes in certain cases in the brain, it can reprogram gene expression. So it can target the brain activity to start encoding genes to develop more tolerance to heat. And the only unfortunate thing is that severe heat can induce neuronal apoptosis. However, hypothermic induction can actually decrease brain injury because it lowers the activity of neurotransmission, brain metabolism, and ion exchange. The only problem with this is that prolonged exposure could risk myocardial depression.
So, in what can be discovered, we have to talk about what currently does not exist. And what currently does not exist is non-invasive ways to actually prevent seizures, right? In order to stop a seizure before it happens, we prescribe drugs. When that fails, we use surgery. How can we actually stop these seizures, potentially as they're happening, using non-invasive stimuli? Well, the research on it is pretty low, and we only find very little literature that actually explains the usage of thermotherapy to stop brainwave activity when it becomes like a seizure. But we can use other methods of actually gaining data on how thermal stimuli would affect brainwave activity. In the middle, you actually see something from a research paper that we saw that applied a hypothermic stimulation and significantly decreased the frequency and amplitude of brainwave activity, such as that is associated with seizures. But on the left and right, you actually see real neural network simulations that were processed in Brian 2 via Python and actually show the application of heating and cooling in order to prevent seizure activity. Things to be considered. Well, there are a lot of things to consider in a project like this. We have to consider things like practicality, accuracy, and the data cost. But we can use databases in order to actually see how EEG data can be analyzed, of which happens on the top. And we can actually see a correlation matrix between seizure activity and non-seizure activity. And we can practically apply them using machines such as NeuroSky. Yep, and these are all 6 of us. These are all the roles we did. I'm Avi. That's Andreas wearing it. Vilmaris is, yeah, raise your hand. Bailey, Kimberly, and Paityn. Here you go.
So currently, do you have enough data available for you to actually prove the concept of this proposal?
So in terms of having enough data, we do have enough data to prove that the seizure data algorithm or seizure detection algorithm that we created using Python actually does work. We used a nationally acquired data set that uses a lot of EEG samples from people with both having seizures and people who didn't have seizures. But for NeuroSky, in fact, the mobile EEG application, we don't have enough data. And that's mostly because there are still kinks and workarounds with using a mobile EEG. Real EEGs have much more sensors and actual signal, and we are only working with one. If we can actually propose using more NeuroSkies and gaining more data, then we can not only perfect the seizure detection algorithm, but also the application of a thermal stimulus.
A couple questions. The Python simulations that you showed, is that something you wrote or something you ran?
It's something I wrote. It's something I wrote in a library known as Brian 2. It's a common simulation software that's used for modeling all kinds of neurons and neural networks. In this specific simulation, we use a neuron population, and specifically, the neuron population is 80% excitatory and 20% inhibitory. These are the ratios that are found in the frontal lobe, and is really important for our population because more excitatory neurons leads to more excitatory to excitatory synapses, which can cause the cascades of excitation seen in seizures.
One more comment. If I'm not mistaken, the NeuroSky was developed by a graduate of FAU who went to the graduate program in the HPBL laboratory, the Human Brain and Behavior. So maybe reach out. They might be interested.
Fantastic.
Thank you. You learn something new every day.